As we said, guys, in the video lecture, if I want to find the acceleration, I can apply the equation of relative velocity and then derive it to find the acceleration. And don't forget that the acceleration is divided into two components: the tangential, that stands for the change of velocity, and this tangential is always equal to alpha cross RB with respect to A, and the normal, which is minus omega squared RB with respect to A, which means it has the direction of minus RB with respect to A. And we said, guys, that we can encounter some cases where, for example, here, if I have two bodies in contact, don't forget that the point of contact has the same tangential acceleration and not the same normal acceleration. And that if I have a rolling motion without a slip, like we're going to do later on, so this rolling motion means that G, the center of gravity, will have a rectilinear motion, all right? Because it's rotating, while G, since it's without slipping, rolling on a surface, on a horizontal surface, then G will have a rectilinear motion, which means it has a tangential acceleration. Only G doesn't have any normal acceleration. And don't forget, since A is my instantaneous center of zero velocity, it will have a zero velocity, which means it will have a zero tangential acceleration, but not a zero normal acceleration. The normal acceleration of A is given as minus omega squared times R. All right? So AA is equal to omega squared times R in scalar form. AG will be equal to alpha times R. All right, guys? So let's apply this to this example. I have a rolling disk here without slipping, such that it has an angular acceleration of alpha is equal to 4 radians per second squared, and an angular velocity of omega is equal to 2 radians per second at the instant shown. Determine the acceleration of points A and B on the link, and the link's angular acceleration at this instant. Assume point A lies on the periphery of the disk 150 millimeters from C. Right? So, guys, I have a rolling disk. Now, let's focus on this rolling disk. From, guys, these slides, I know that the acceleration of C, which is the center of this disk, will be horizontal, and this VC also will be horizontal. So, AC will be equal to what? AC will be equal to 4 times the radius of this disk, which is 0.15 I. All right? All right, so guys, you can memorize this. If I have a rolling disk without slipping, then the center of gravity will have an acceleration, a horizontal acceleration that's equal to alpha times R, while this instantaneous center of zero velocity will have only a normal acceleration that is equal to omega squared times R. All right? So now what is AC? AC will be equal to 0.6 I. Now I know AC. I can find AA, guys, right? By applying the equation of acceleration in vector form. So what is AA? AA will be equal to what? It's equal to AC plus alpha of this disk cross R. Now it's not the radius like here, it's RA with respect to C. All right, so this is the relative acceleration minus omega squared RA with respect to C. And don't forget that RA with respect to C is CA. All right, so it's in the positive J here. Okay, so what is AA? AA will be equal to 0.6 I. Now, guys, I want you to know that if I know omega and alpha, I cannot assume their directions. Remember, guys, in the case of velocity, if we don't know omega, we can assume its direction, and then let's say we can assume it in positive k. Then if the value is negative, it's in the negative k. If the value is positive, it is in the positive k. However, here, guys, I know omega and alpha. I know them. I know their values. So I cannot assume their direction. I should find their direction. Don't forget, guys, that if this is I and this is j, then k will be k will be towards me. Right, towards me. Now, since omega here and alpha, they are in clockwise, then they are towards you, guys. All right, which means they are in minus k. So minus 4k cross RA with respect to C, which is CA 0.15J minus omega squared, which is also 4 since omega is 2, times, it's not a cross product, it's a vector, right? RAC is a vector and omega is a scalar value, right? So times 0.15J. So this is the product of a vector times a scalar, right? Which means, guys, that AA will be equal to 0.6I. K cross J is what? K cross J is minus I, and I have a minus sign here. So minus 0.6I. Plus, because K cross J is minus plus. Minus 0.6J. Alright? So this will give you what? 1.2I minus 0.6J. Now, guys, you can ask me why you did not do this using the instantaneous center of zero velocity. Yes, you can. And you're going to have the same answer. But don't forget, guys, that this instantaneous center of zero velocity will have a normal acceleration that is equal to what? It's equal to omega squared, 4 times 0.15, which means it's equal to 0.6J. All right? So here, instead of AC 0.6I, you're going to have 0.6J. Okay, guys? And then instead of RA with respect to C as 0.15J, you're going to have 0.3J, right? Because it's the whole distance now. And then this is also 0.3J. If you do it, you're going to have the same answer. Okay, guys? Now, am I done? No, because in fact, I need to find AA and AB. What about AB? Guys, how can I find AB? If I put the equation of relative acceleration between A and B, I'm going to have a lot of unknowns. I'm going to have 3 unknowns, in fact, because I'm going to have AB. I know that AB will be horizontal because B is moving in a horizontal direction at this instant. So I'm going to have AB tangential. It doesn't have an AB normal because it has a rectilinear motion. And I'm going to have omega AB and alpha AB. So 3 unknowns, which means I can't find them. What if I put the velocity at A and the velocity at B? What is the velocity at A? The velocity at A will be perpendicular to the line joining A with the instantaneous center of zero velocity, which is here. All right? So this is VA. I'm not talking about AA. AA has two components, A tangential and A normal. So it's not horizontal. But VA is horizontal because it should be perpendicular to IC. And I know that VB is also horizontal because it's moving on the horizontal line. And this means, guys, I know both directions. So let's draw the instantaneous center of zero velocity. This instantaneous center will belong to what? To the perpendicular line to VA. So this is the first perpendicular line, as well as to the perpendicular line to VB. Is there any intersection between these two lines, guys? Is there any intersection between no, which means IC is located at infinity. And this means, guys, that omega AB at this instant only is equal to 0. Only at this instant, guys, omega AB is equal to 0. Guys, at the next instant, for example, if A is here, then A will not have this velocity. It will have this velocity. And in this case, I'm going to have IC and I'm going to have omega AB. But at this instant, guys, omega AB is equal to 0. And I'm going to use this fact to find AB. All right? I'm going to use this fact to find AB. At this instant, omega AB is equal to 0. It doesn't mean that alpha AB is equal to 0. But at this instant, the angular velocity is equal to 0. So I can now find AB. because I got rid from one unknown. So AB is equal to A plus alpha only cross RB with respect to A minus 0 since omega is 0. At this instant, so I'm going to repeat, it's only at this instant, all right? Now, what about AB? AB is moving in a rectilinear motion, doesn't have any normal acceleration, so it only have a tangential acceleration, which means ABI, so I only have one component in I direction, is equal to AA that I found, which is 1.2I minus 0.6J. Right, plus alpha that I need to find K cross RB with respect to A, which is AB. Now AB has a positive I, a negative J, so it is 400I minus 300J. So let's write them in meters. 0.4I minus 0.3J. So now you can do the cross product. K cross I will give you J, K cross minus J will give you I, right? And this means that ABI, what are the components in I? I have 1.2I. K cross J is minus I, minus plus 0.3 alpha I. This is the first equation. I don't need alpha, I need AB, in fact. And the second equation is that 0 is equal to minus 0.6J plus 0.4J. So now you can find 0.4 alpha J. So now you can find alpha, and from alpha you can find AB. All right, guys, any question? Any question, guys? No question at all? Noor, can you please repeat why is it in minus K? Okay, Noor. Okay, Noor, can you use your right hand rule to find what is the direction of K? If this is I to the right, J upward, then K will be towards me and not towards the screen. All right? Okay. Now use also your right hand rule and rotate your right hand with omega clockwise. So what will be omega in vector form? It will be towards the screen, okay? Which means it is in minus K. You got it, Noor? Okay. So Noor, this is my right hand. This is my right hand, okay? If I do I, J, K, then K will be towards me. Okay, Noor? Now, the question is that alpha and K are in clockwise, which means it is towards you. Okay? So did you see this rotation? So it is in the opposite direction of my K, and that's why it's in minus K. Okay? All right.